Welcome back to another video. This one's just a practice paper on P1. I wrote the questions myself, but I've based it on the October 2023 paper. Okay, so the questions are similar to that, similar style, similar topics to that question. So let's get started. And don't forget to subscribe to my videos, comment if you have any questions. Best way to kind of use this video would be to, pause it after each question, have a go at the question, and then play to see it happening, or, just skip through the video to get the questions, have a go at them all, and then watch the video back then to see how to do it. In fact, I think I'll make a PDF of the questions and I will put it in the description, the link. So let's get started. Okay, so this first question is a nice straightforward differentiation. The first thing you want to do is make sure everything's on the top, so you want to get this x cubed onto your top line. So the first step will be to rewrite it. So we get 3 to the power x to the minus 3 plus 9x. And then from here it's pretty straightforward, just differentiating. So multiplying by the 5, we get 40x, and taking 1 away from the power. Minus, and again now we're multiplying by the power, minus 3. So that will turn this into a plus 9x, and take 1 away from the power. And then finally we've just got 9 at the end there. Obviously multiplying by the power, which is just 1. Taking 1 away from the power, which is 0, hence the x disappearing. So that's part A, nothing more to do there. I often put this back down the bottom just because I like to leave a question in the same style as, leave an answer in the same style as a question, but there's no need to, and I take extra steps where you could make a mistake and then potentially lose some marks, isn't it? So let's leave it there. Then we're going to differentiate a second time. So 4 times 40 there would be 160x cubed, minus 4 times 9, so it's minus 36x to the minus 5, and then obviously this one's going to disappear then. So that's the first question. Easy marks there. Just a straightforward differentiation. Okay, second question now is with indices. So it's just about applying the rules of indices. So it's a slightly different style to how we often see these indices questions. It's possibly something that might be asked a bit more in the future. It hasn't really come up very often in this kind of style, but there's nothing too difficult to it. So if I look at the first one, we've got a to the power 1/3. So we write down a and raise it to the power 1/3. Now, third is obviously cube rooting. I need to make sure I do that to this number here. So we've got, the number 1/3 or cube root. This would give me a half, cube root of 1/8. And then x, and with the powers, we multiply them together. So 3 times a third is the power 1. So that is just it, half x. Moving on to the next one, we got 9 over b cubed. So that was 27 cube root of x cubed. So 27 cubed, it's quite a large number, 19,683 over, and then cube root of x, and then cubed would just be x. And this is obviously, this is the same as that times x over that. Okay, so you don't have to write that line. I wouldn't write that line normally, but you know, it's just there to help you see it or think it. And just simplify and dividing by the 9, or you know, simplifying with 9 or dividing both numbers by 9, however you want to think about it, will leave me 2,187 on the bottom. Again, you know, it's fairly straightforward. You just have to approach it kind of logically or methodically. Now, this final one here is obviously a little bit different. We can go ahead and we could multiply, because we've got AB, we can multiply our AB together first and then put it inside this. Or we can deal with this and the minus 2/3 and then put in our A and B. I'm going to put our AB together, so I'm going to go AB first. So x cubed over 8 times 27 over x to the power 1/3. And just writing it as that fraction there, just to make it easier. So 27 over 8. Now x to the power 3 over x to the power 1/3. Now that would mean that I'm going to be minusing 1/3. So it's like 2 and 2/3. Or as a top heavy fraction would be just 8 over 3. Now that I've got that, we can go ahead and put it into the form of the question. So we got 2 over 3 times 27 over 8, x to the 8 over 3, and of course this is to the power minus 3 over 2. So this will cancel, so 2 will cancel with 8, leaving me 4, 3 cancelling with 27, leaving me 9. And I like to write these as a positive power. So we've got 9 over 4 becomes 4 over 9, x to the minus 8 over 3 there. And that would now be to the power 3 over 2. Of course, you can do this in your calculator, but it's quite straightforward. So the 2 on the bottom is square root, and the top is to the power 3 cubing it. So square root of 4 is 2, and then cubing 2 is 8. Square root of 9 is 3, cubed is 27. Getting back to the same kind of values as before. And then we've got 8 to the power. Now, the 3 can cancel too, so this is going to be minus 4. You know, when you multiply these two together, you know, the 8 will divide by 2, leave me 4, and the 3 will divide by 3. So, leave me 1, you know. So you got 8 over 27, x to the power minus 4. You could rewrite it and have 8 over 27 x to the power 4 if you would prefer. Okay, and that's all there is to it. It's just being methodical. Yeah, be careful with your numbers, be careful with the signs. Remember what they all mean. So the minus is like a 1 over. Or if it's a fraction, it means you can just flip them round to turn it into a positive. Okay, so this would have been on the bottom, you know, when I turned it onto the bottom, or rewrite it just as a negative power there. So hopefully that is not too bad. I think still relatively straightforward. So we have a surd here, and we're effectively got to be simplifying it and, well, rationalising it. So let's make a start. If I look at the bottom, that will tell me what I need to do here. So we get 61 root 14, and then it's 3 root 7 minus root 2. And so I'm going to need to multiply by root 7 plus root 2. And of course not missing the 3 that appears in front of the root 7 there. So on the top we've got, well, 3 times 61 is 183. And root 14 times root 7, well, 7 times 14 is 98. But I might want to think of it like, 14 is 2 times 7, isn't it? And then we times in by the other 7. So that's where my 98 comes from. 2 times 7 times 7. But this 7 times 7 is going to be quite important for us because 7 times 7 is 49, which is obviously a square number. So that is how I'm going to be able to simplify that one in a little while. So we've done that. Then we've got, again, it's plus 61. And we got, if I write it again, so 2 times 7, that was the 14 there. And then this time times 2. So you can see that the 2 times 2 is going to be a square number, which will allow us to simplify that. So just rewriting, splitting up that 14 into, these numbers will just make your life a little bit easier. Now onto the bottom, we've got 3 root 7 times 3 root 7 is effectively 9 root 49. I'll write it like that. I wouldn't normally. I'd probably skip to the answer, to be fair. The middle ones will cancel out, so that is 3 root 14, and that's minus 3 root 14. So they will cancel out. And then we've got minus root 2 times root 2, so minus root 4, which is obviously just 2. But I'll take extra steps just to help you guys out. Now, 183 times 7, so we get 1281 root 2 there. So that's square root of 49, which is 7. So 183 times 7, and then obviously we're left with the root 2. And then we've got on the next one 61 times by 2, 122, and that's root 7. So you think about it, that's square root of 4, which is 2. 2 times this is 122, and then obviously we're left with just the root 7. On the bottom, we got 9 times 7, which is 63. So 9 times 7 here, 63, minus 2 would be 61, which is nice because obviously we had this was multiplied by 61 at some point here, and this was multiplied by 61 at some point, so they should cancel. So 1281 over 61 leaves me with 21, so 21 root 2 plus, and then 122 divided by 61 we'll remember is 2, so it's 2 root 7. So there we have, just having it. Sorry, I had a sudden cough coming on then. Just putting it now into the same form as the question. So 2 root 7 plus 21 root 2. So there we have A is 2 and B is 21 there. Okay. Now, with this next question, we've got to, solve for x. Oh, I feel like my voice is terrible today. Yeah, so the next question we've got to solve for x, and we need to be looking at this being in some sort of form like we have here should make it a little bit easier. Now, don't know how to approach this initially, so I think I'll start by expanding the brackets. So 3 root 7x minus 183 root 2, and that's times 3 root 7 equals x over root 2. I want everything with x on one side. So 3 root 7x minus x root 2. 183 times 3 is 549, and over to the other side it becomes positive, and root 2 times root 7 is root 14. So we're looking like we're going to get something like this. So factorise out our x, we've got 3 root 7 minus root 2. There we have it. 9 root 14. So x equals 549 root 14 over 3 root 7 minus root 2. So this is almost the same as this one now, isn't it? In fact, it's just, we haven't got the 61, we got 549. So let's see if we can divide by 61 on a calculator. And we can. So we can take out, so it's 9. So take that out, 9, and we get 61 root 14 over 3 root 7 minus root 2. Now this we can swap for this. So that comes 9 brackets 2 root 7 plus 21 root 2. And then I can expand my brackets, so we've got 18 root 7 plus 189 root 2. And there you have it. So not too difficult. It wasn't obvious in the beginning, but I knew we shouldn't divide by this because then we've got a fraction here and we've still got bits and pieces, and there's an x and there's an x here. So that's why I decided to expand first. And the more kind of maths that you do and you practice, the more questions you try, the more you can start to see patterns or to have an idea how to start a question, even if you can't see it all the way through at that time, at the beginning. Okay, next question, fairly long. We've got figure 1 here, shows a sketch as part of the curve C with equation 4 over x minus 1. State the equation of the asymptote of C that is parallel to the y-axis. So this dashed line is what we are trying to label or name. So just taking a little bit more space. Make sure there's plenty of space for me to write, but you've got this line. It's quite an easy one for your asymptote. You've got it here. So looking at this, what's impossible? Yeah, and it's impossible to divide by 0. So if I make the bottom of this 0, so x minus 1 equals 0, x equals 1. So when x equals 1, this is impossible. That is one of my asymptotes. Okay, in this case, it is the asymptote that we want. Okay, moving back to the question as a whole, the next part is just to fully factorize this. So, fully factorising x cubed minus 2x squared plus x. It's a nice, easy one, isn't it? X is in everything, so we can take that out, leaving us x squared minus 2x plus 1. And then we've got, so that's x. Both of these are x. It's a positive value here, so both the signs have got to be the same. This is negative, so both the signs have got to be negative. And it's got to be 1, hasn't it, to make the 1. 1 times 1 makes 1. Let's check it. So you've got x squared minus x, that's minus 2x, and that would give me plus 1. So this is x minus 1 squared, and that's fully factorized. Okay, now part C is on diagram 1, figure 1, add a sketch of this curve. So the one you just found there, or factorized. On your sketch, state clearly the coordinates of each point where this curve cuts or meets the coordinate axes. So not where they intercept, but just where they meet the x and the y axes. So let's put this on the diagram. So we've got this one here, so it means that x is equal to 0, x equals 1 twice. That's how we think about it. So x equals 0, it's going to cross at 0. X equals 1, it's going to touch at. That's the same as the asymptote. It's a positive x cubed graph, so we know it's going to start at the bottom, cross through here, come down, touch, and go back up. Okay, so something like up to there, come round. That's probably not the best diagram. You won't get to see that because I'll rub it all out. So up, and I've got to touch at this point, so you want to go up, kind of symmetrical there, touch there, and then heading back up. Okay, and obviously you just want to try and get it nice and smooth. Okay, so we're left with something like that for part C. Now, part D I've just stuck on here, so we got like, hence state the number of real solutions when this is multiplied by this, and it equals 4. So if we rewrite it, it's x cubed minus 2x squared plus x equals 4 over x minus 1. 4 over x minus 1 was the original, and this is that new one, the one I've drawn in black. So it's just where they intercept. So I'll circle it with a red pen here. So they intercept at this point and this point. So I can say that there are two number of real solutions. 2 real solutions. There we are. And it says given a reason for your answer, and that's where this came in. This was important here. It's because you just want to say that this is the same as this. So it's where the two graphs intersect each other. Okay, so same as that. So you could just say, this is the same as the question, however you want to say that. Therefore, where two graphs intersect each other. So something along those kind of lines, yeah? But make sure you have that rearrangement so you've got the two separate graphs, one either side of the equals, so that you can say they are the same. So here we have some information. We've got triangles, 2 of them, or 3 of them, however you want to look at it. Information here, but it's all on the diagram. Show that this equals this. Now, it's not a right angle triangle. There's no right angle triangles here. So if we want an expression with cos theta, we need to be using the cosine rule. Okay, and we want it for the angle. So for part A, your cosine rule is, let's see. Let me first write this in terms of like A, B, and C, because it's a little bit easier to remember. So this is B squared plus C squared minus A squared over B, C, cos A. Okay, so that's what we're looking at, the rearranged formula here. So cos theta, now A is going to be opposite it, the 5. The other letters doesn't matter which way around. So x squared plus 3 squared minus 5 squared. 3x cos theta. And then it's just a matter of simplifying this. So this is now x squared minus 16 over 3x. I made a mistake. So it's 2bc, isn't it, on the bottom? And I don't know why I would put the cos A again. What an absolute idiot. So 2bc, so that's 2 times 3x. And then that means that this bottom one here is 6x. Oh, lucky the question give it to us, because that was a really silly mistake. But quite easily done, you know. So this one luckily had the answer. Sometimes you just have to be able to kind of recognize where things are wrong. I wouldn't have recognized where this was wrong initially, but when I go back and check through my work, I would have then spotted the 2bc. It's important to be able to save yourself enough time at the end of an exam to properly check your work there. We also need to find one for cos alpha. So that is going to be the same. Not actually the same, but you know, the same method there. So the one opposite is going to be with my A, the 6. The others don't really matter the order. So x squared plus 1 squared minus 6 squared over 2 times x times 1. So here we have x squared, and it's 1 minus 36, so minus 35 over 2x. Okay, part B now says, hence or otherwise, show that x equals 5.5. So the first thing we're going to be looking at is the fact that theta plus alpha equals 180 degrees. Yeah, they're on a straight line together, so they must total 180 degrees. So theta would be 180 minus alpha. So what I can do from here, I can say is cos theta must be equal to cos 180 minus alpha, as they're both the same thing, the same size angle. And what I can say from that is that 180 minus an angle is the same for cos as minus cos alpha. So these two things are the same. So now we've got cos theta equals minus cos alpha. And cos theta, as I can see up here, is x squared minus 16 over 6x. So x squared minus 16 over 6x, and minus cos alpha. Now, because it's minus, that would be the same as, instead of having x squared minus 35, we'd have 35 minus x squared. Imagine if you multiplied by minus 1. So 35 minus x squared over 2x. Now, if I multiply by the 6x over to the other side, the 6x will cancel with the 2x and just leave me with 3. So that is x squared minus 16 would become 3 lots of 35 minus x squared there. Or x squared minus 16 is equal to 105 minus 3x squared. So 4x squared equals 121. X squared would be 121 over 4. And if you square root it, obviously plus or minus, but it is a length, so we just want the positive. So that would be 11 over 2, which is 5.5 as we required. Okay, so we could have done it, we could have swapped this around the other way around. It wouldn't have made a difference. We still would have got the same answer out. Now, there's lots of different ways to find the area of this triangle. I mean, ultimately what I have in my head is that I'm going to end up using a half AB sine C to find the area. It's non-right angle triangle. That is what I'm going to do logically. Now, to be able to do this, sine C, I would need either this angle here, so I need this one and this one, or I'd need this angle here at B, or this angle here at C. So a few ways to do it. Now I'm going to go with this point. Now I'm pretty confident that this one is correct, and I've shown this to be correct. But since they gave us this and they've given us this, I'll use these two, okay, to be safe with this final part of the question. And this will allow me to find theta. So cos theta is 5.5 squared minus 16 over 6 lots of 5.5. And then, of course, I want to inverse that for theta. So actually, I'll tell you what it was before I did the inverse so that you can check your answers. And then when I inverse cos, I get 64.4 to 1 decimal place. But I'm going to store that in my calculator as A, and I'm going to use that in a moment. Now, what I want to do here is say, right, well, let me find this angle here at B. Okay, since this is B, I'm going to call it beta, just with my setting it out. So I'm going to say, and I'm going to use the sine rule. Okay, so we've got here these, and then these. So I can say, right, I want to find beta, so sine beta is over x, which is 5.5, and that is going to be equal to sine theta over 5. So sine beta equals 5.5 sine theta over 5, and therefore beta will be, so 5.5 times sine, and I stored it as 8. There we are. divided by 5. So this gives me 0.99. Shift cos. And I get a very small angle, 7.18. Yeah, it felt wrong, and I just double checked it. I don't know what I did there. I must have hit Shift cos. So it's 82.8 there degrees, and that is to 1 decimal place. And I'm going to store that as B. You know, to put the little letters next to the angles or the values that I store in my calculator, because it makes it easier and I can use that full value. But yeah, I'm storing that as B. And the reason it didn't make sense is that this side 5 and this is 5.5, they're nearly an isosceles triangle. They're very close in size, so these angles should also be fairly close in size. So coming out with 7 degrees obviously just seemed really wrong. Okay, so coming back in with something that is 80 odd degrees, it seems far more realistic. Now all I need to do is fill in my values for the area. So it's half. Now since I'm using this angle, my A and B will be this 5 and this 4. So it's half times 5 times 4 times sine 82.8. But of course I'm going to use the full value. So half times 5 times 4 times sine, and it's B because that's what I stored it as. And that there gives me 9.92 units squared, and that is to 2 decimal places or 3 significant figures. Okay, so there we have our area. There we have all our working out. Again, it's not a difficult question. You just have to follow the steps through. Some steps that they weren't really obvious in the beginning, and it just kind of, you know, what I tell a lot of my students is that, you know, once you practice, it does make it easier because you kind of get more options. You get used to how questions are. But when in doubt, start off by thinking of, right, what can you do in the question? And that sometimes, or well, more often than not, leads you down the right path. Okay, so next question. We've got an equation here. Not too bothered about how it looks. Looks interesting. But what's key is, you know, what it says. It has no real roots here. Yeah? Has no real roots. So if something has no real roots, my first thought will always be b squared minus 4ac is less than 0. So you see that, and that is what you immediately think. Might not always be the case, but 9 times out of 10, that is what you think, and that is what you're going to use. So let's look up here. We've got something x squared, something x, and something. So that is my a, my b, and my c. So b squared 2k squared minus 4 times k minus 1 times 7k minus 4. And that would be less than 0. Okay, so it's obviously not like this at the moment with a greater than 0. But that is less than 0. So let's expand and sort out. So 4k squared minus 4, and then I'm going to expand my 2 brackets first. So k times 7k is 7k squared. K times minus 4 minus 4k. Minus 1 times 7k is minus 7k. Minus 1 times minus 4 is plus 4. Okay. And then just having the same again, but simplifying or sorting out that middle, that would give us the minus 11k plus 4. Now, what I want to do is multiply through by 4. I mean, ultimately at this point, I've got a 4 there, I've got a 4 there. I could go ahead and divide by 4, and I think I might actually do that. You know, it's like taking a factor of 4 out of this, isn't it? Take the 4 out and the 4 out of there. So I could just divide by 4, save myself a little bit of effort. Get rid of my brackets, so minus 7k squared plus 11k minus 4. We've got minus 6k squared plus 11k minus 4. And then taking everything to the other side gives me k squared, or 6k squared minus 11k plus 4. And that is what was required. Okay, so I would write it again just like this, but that is me. You could have left it at this point. So that is nice easy question, or at least part A. But it's just remembering that has no real roots, has one equal root, real root, you know, has real roots. Just remembering what that kind of implies. So hence, using algebra, find the range of possible values of k. So we're going to be using this, aren't we? So starting with now my 6k squared minus 11k plus 4 is greater than 0. It's nice that they do this as a show that. Means you can still access part B even if you can't do part A. So just checking they're both minus, aren't they? So there we have it. You've got your 6k squared minus 3k minus 8k. That would give me the minus 11, and minus 1 multiplied to give me 4. Okay, little hint, you can always put this into your calculator, see what your two answers for x are, you know, so it would have given you in the calculator x equals 4/3 and x equals a half. So you can build that back up. Well, that's 3x equals 4 and 2x equals 1. So 3x minus 4 equals 0 and 2x minus 1 equals 0. And 9 times out of 10, that is your two brackets. Sometimes there might have been some sort of simplifying going on with the fraction, might have been, you know, something that's simplified. So you might need to multiply these by a value. But it just, you know, using the tools you have at your disposal just to make your life a little bit easier. Right, so at this point, what I want to do is I want to talk about my critical values. So my critical values are k equals 4/3 and k equals a half. Okay, important, you know, that you are talking about critical values, because these aren't necessarily answers. As you can see, it's greater than 0. Yeah, so it's not going to include these particular values. And then you want to show you working out. A simple sketch is good enough for that. It's a positive x squared, you know, when you look at this here, 6x squared, you know, goes through 4 on the y-axis, hits the half, hits the 4/3, you know. It would look like this. It would hit that 4 We don't need that value. We don't really care about that value. But there's our half, and there is our 4/3. Okay, those are the important two values there, the critical ones. We want where this graph is above the line, which is here and here. So that means we want all the x values to the right of 4/3 and all the x values to the left of a half. So that enables me to say what the possible values are for k now. So k is less than 1/2 or k is greater than 4/3. And that is my answer. Okay. I wouldn't put them together. They're two separate regions. Look, we've got two separate regions. If we were using the center region, then I would combine them into one inequality as it's one region. Okay, and that's the easiest way to think about it. It's important, you know, I see a lot of people, they get the critical values, but they're not entirely sure, and they often just put them as both greater than or both less than, and I haven't thought it through. Okay, so it's the critical values, sketch of your quadratic with your critical values on it, and then if you want above the axis, you need to look at where the line or your graph is above the axis. If you want less than 0, you'd be looking at where it's below the axis. Very, very straightforward and simple, but you must do this logically. Okay, we're getting towards the end of the paper now. It's usually when some of the questions get a little bit more challenging, but not always. So the curve C has equation y equals f of x, blah blah, where x is greater than 0. It gives us f dash of x, so we've got the differentiated version of this, which is here, and we've got a point. Find the value of the gradient of c at p. So that's very nice and easy for the first part, isn't it? So f dash of 4 is what we want, because up here there is a value for x. So 54 times 4 cubed, well, it's 2 lots of 4 over 2 lots of 4 to the power 3 over 2. And it's just a matter of simply inputting this into my calculator now. And the value I get is 431 over 2, or 215.5. So hence find the normal. Well, if we're going to find the normal, we want to say what the gradient to that is. So, you know, flip it, change the sign. So a gradient of our normal, I'll put len for normal, that is minus 2 over 431. And then we've got at the point 425. So that's what we've got. We've got to find it in the form ax plus by plus c. Sorry, just moving that there to make it easier for me. So y minus y1 equals mx minus x1. So y minus 25 equals minus 2 over 431 x minus 4. Not particularly nice, is it? 431 y minus, now 25 times 431 is a very large number. And we've got minus 2x plus 8. Take the 2x over the other side, 2x plus 431y, and then we've got a minus the 8, so 10, 7, 6, 7. And there we have it. So not particularly nice numbers, almost feels like I've done something wrong. Let me know in the comments if I have made a massive mistake, but it feels right. You know, the 54 and stuff, that is quite big. It is already in that form, so yeah, I don't think I've made a mistake. Part B, find f of x. So now we need to integrate, don't we, this. Now, before integrating, I'm going to simplify it. So we've got f dash of x. So I can, with the 2 on the bottom, I'll write it out actually. 54 x cubed minus 2x over 2x to the 3 over 2. So cancel the 2, become 1, and that will become 27. I can then divide by the 3 over 2, so I get 27x to the 3 over 2 minus x to the minus 1/2. Now integrating, so 27x to the 5 over 2, adding my 1 and dividing by that, minus x to the 1/2 divided by 1/2, and then plus c. Just trying to squeeze it in at the end there. So let's sort this. Let me just sort out some space here. That's better. It's getting rather cramped in that corner. So f of x equals, so this is now 54 to the 5 over 2, and that's over 5. This would be minus 2x to the 1/2 over 1 plus c. Now this is where this coordinate comes back in. We can use that to find c, because f of x, obviously it goes through that point, it lands, p is on that. So f of x, don't know why I'm writing that, so f of x would be worth 25 when x is 4. So 54 times 4 to the 5 over 2 over 5 minus 2 lots of 4 to the 1/2 plus c. Therefore, f of x equals 54x to the 5 over 2 over 5 minus 2x to the 1/2 minus 1583 over 5. Doesn't look nice, does it? Have a check through when you ever go at this, see if I've made any silly mistakes. Can't spot any initially here. I'm sure in an exam they try and find some slightly nicer values to use, but hey, this is what we got. I guess what happens sometimes when you just make a question up. Okay, so here we've got the coordinates A, B and C, and they're both compared to this BC, aren't they? Parallel or perpendicular. So let's have a look at the gradient of BC. So gradient of BC. So difference in y's, 12 minus 8. Difference in x's, minus 5 minus 3. Remember to go from the same one, doesn't matter which way. So I went B take away C. You could equally do C take away B. Should give you the same answer. So here we got 12 minus 8 is 4, minus 5 minus 3 is minus 8. So we got minus 1/2. Okay, now this line is parallel, the one we're going to do first, L1, pass through the point A, and this is going to be its gradient. So using your y minus y1 equals mx minus x1, we'd have y minus 10 equals minus a half x minus 11. Okay. So I'm going to multiply here by 2, and then I'm going to expand that bracket. So multiplied by 2, I get 2y minus 20. And then that actually means this minus 1 times these. So that'll be minus x, and it's a plus 11, so it'll be minus 11 there. Now you can see we want the x and y's on the same side. They're positive. So taking the minus x to this side and then adding 11. So we get x plus 2y minus 9. And then that is as required. So that is L1. Okay, now L2 passes through C and is perpendicular. So L2 is going to have a gradient of, now it's flip and change the sign, so it's going to be a positive 2. And of course it's going through C, so that means it's got the coordinate 3, 8. And again with a y minus y1 equals mx minus x1. And that gives me y minus 8 equals 2x minus 3. So we got y minus 8 equals 2x minus 6. That means if we add the 8, y equals 2x plus 2. And that there is L2. Now, L1 and L2 intersect at point D. So we need to find their intersect and find the length of BD. Okay. So finding D first. Now, if we look here, this is a y equals. So what we can do is we can substitute this into here, replacing the y. So equating my two equations, I'd have x plus 2 lots of, and then inserting the second one, 2x plus 2 minus 9 equals 0. So x plus 4x plus 4 minus 9 equals 0. 5x minus 5 equals 0. And we can see what it is. 5x equals 5, x equals 1. And then if I substitute into this equation to get y equals 2 lots of 1 plus 2. So y equals 4. So coordinates D is 1, 4. Now we need to find BD. So we got the B's coordinates was minus 5, 12, and D's coordinate is 1, 4. And this is effectively just like Pythagoras, isn't it? You know, B could be, if I just put a rough position for it, say B is here. And then D would be, you know, somewhere like that. And it's just a diagonal line. Oop, that's not very good. That's better. And it's just a matter of looking at the horizontal and vertical distances. So minus 5, 12 and 1, 4. So you can see here the horizontal distance is 6, going from minus 5 to 1. And the vertical distance is 8, going from 4 to 12. So using Pythagoras, it should be quite straightforward. You know, it's going to be 10, isn't it? Because it's like a 3, 4, 5 triangle where they're all doubled. Okay, so you know BD here is 6 squared plus 8 squared. square rooted. So it's just going to be 10. But obviously you don't have to sketch it out like that. You can remember that the distance is square root of, and it's the difference in your x's. So x2 minus x1 plus, and that's squared, y2 minus y1 squared. So you can just write it as a formula. Okay, but that's the question done. Okay, so we've got a discus. So we've got the circle where they obviously spin around and throw the discus, and then the area that they're throwing it into. Target area, right. So PS is 1 meter. So this arc length here is 1 meter. P and S are on point C, yeah. So that's the sector of a circle, center 0, and so let's just start putting some values onto our diagram. So that's 1 meter. That has an angle of 0.5 radians. PQ is X. So this is X. OQRO is 1225. That's about it. So we need to show that the radius OP is 2 meters. Right, let me make some room. Much better. So let's look at part A. So we know arc length equals r theta. We know that the arc length is 1, and we know that theta is 0.5. Okay, or I could write that as, a half r. So it should be pretty obvious. Multiplied by 2, r is going to be 2 meters. So that's the first part. We've shown that. Nothing too difficult there. The next bit, we need to show that the area of the target area is this, x squared plus 4x minus 4896. So target area is obviously this inside. So we need the whole sector, or the large sector, so to speak, which would be like from O to Q to R and back to O. And then we need the small sector here, OPSO, and take them away from each other. So area OPSO. So this is a half r squared theta. So that's a half times 2 squared times a half. 2 squared is 4, and a half times a half is a quarter. So this is an area of 1 meter squared. So we want area PQRS is what we want, and that is area OQRO minus area OPSO. So area OQRO is 1225 minus 1, so 1224. Now we're going to do the same again, PQRS. So area OQRO, the larger one, would have, so it'd be a half r squared, so x plus 2 squared. Theta is a half. So that is just simply, the radius of 2 and the x. So x plus 2 is this distance, OQ. And then that's a half. And of course then this is going to be minus the area here, which is just going to be 1. So we've got a quarter x squared plus 4x plus 4 minus 1. And what I've got now is that this is going to be equal to this. Hopefully I've not made any mistakes. So let's see, quarter x squared plus 4x plus 4 minus 1 equals 1224. So quarter x squared plus 4x plus 4 equals 1225. Times by 4, so we get x squared plus 4x plus 4 equals 4,900. And then taking it away, x squared plus 4x minus, so taken away from 4, we get 4896. And that is what we needed to find. Okay, so that is for my area of the target area. Now, part C, we have to find the perimeter. Okay, so first thing we need to do is find that value of x, and that means solving this quadratic. So there's a few ways to solve it. You can, of course, use your calculator to kind of cheat, if you will. So that was my bracket. So x is 68 or x is minus 72. So 68 is the one we're going to need. Now, before we can solve it, we're also going to need Q to RQ, this arc length, aren't we? Okay, but we needed x to be able to do that. So we want the arc length. So we want L, but the arc length, that is RQ. And that's R theta. Now R is going to be 68 plus 2. And theta is a half. So 68 plus 2, because it's 68 is the x and the 2 for OP. So that's basically half of 70, so that is 35 meters. Okay, so we've got 1 meter. If I put these on now in red, just so you can see, well, the 1 meter is already there. We've got 68 meters here. This is going to be 68 meters because it's also a radius. And then this one's going to be 35 meters. So our perimeter is 68 plus 68 plus 35 plus 1. And that's 172. Says to the nearest meter, but that was when I was just writing the question. I wasn't entirely sure about what the answer was going to be. So yeah, it was exact in the end. Brilliant. Okay, so what we got here is a sketch, part of the so it's a sine graph. Now here we can see that this is 180 degrees and 0, and that's point Q, which is here. And we want to be able to work out the value first of n. So we can see here this is one period or cycle, yeah? So just one period or cycle to here. Now Q is at 180. Obviously we want to look between 0 and 360. That's what it would normally be for this sine graph over here. So if we go 1.5 to 180, and then if we think to 360, we'd have 3 complete cycles or 3 complete periods. So that value of n there is going to be 3. Sorry, just making a bit of room there. So our value of n is 3. So we actually have y equals 2 sine 3 theta. Okay, now stating the period of C. Don't know why I've put C1, it looks like there. Yeah, so stating the period of this curve C, we would be looking at, right, so if it's a 3 theta, and normally it's between 0 and 360, isn't it? So sine x is between 0 and 360. So when it's sine 3x, we end up with 3 kind of full sine graphs, if you will, full periods. Okay, so obviously it goes on forever, but I'm just talking about the shape of one period here. So we would want there to be 3 between 0 and 360. So this would be between 0 and 120. So dividing that 360 by 3. And obviously if this was in terms of radians, we would divide that 2 pi by 3. So this is going to have a period of 120 degrees. Yeah, so every 120 degrees we get a complete period, okay, or cycle. Now for the next bit we need to state the coordinates here of P. Okay, it has a maximum, so we know that at P there it's the maximum point. So it's not too difficult. We've got a 2 in front of our sign, so obviously we're multiplying the y values by 2. It's normally between 1 and -1, so it's going to be between 2 and -2. So P is going to have a height of 2. Now what we need to do is work out its x value, its theta value in this case, the horizontal bit. And we could work it out from here. We could think about our 120 degrees and what that normal point would be, and remember then we're just effectively dividing by a third. So, you know, in a standard graph, which is between say 0 and 360 would be here, P would be at 90 degrees. But because it's a third of the size, P is going to be at 30 degrees, a third of that 90. Okay, so we can look like that, but it's just a little bit of manipulation and thinking, you know, a bit of proportionality, I suppose. But it's not too difficult there. Okay, now I can see where the C1 is because we've got a second curve. The curve C2 has equation y equals sine theta plus k. So same kind of graph, but obviously it would be like one loop to here and then they carry on there. Where k is a constant. The point R is a 2/5 and the point S is minus a 3/10. Both lie on C2. Given that A is a constant less than 90 degrees, find the value of K. Well, I guess there might be more than one way of doing this, but immediately what springs to mind is to effectively substitute into what we've got there. So, you know, 2/5 is equal to sine A plus K, and 3/10 is equal to sine minus A plus K. And sine of minus A is the same as minus sine A. So that's what we've got. So sine A equals K minus 3/10. And if I stick that into here, hopefully we'll be able to work something out. So 2/5 equals k minus 3/10 plus k. So I've got 2k on the right side, and I want to add 3/10, so that's going to be 7/10. And then divided by 2, so k is 7/5, or was it 1.4? And there we have it. Weird that this is one of the last questions in the paper. Very easy question there. This question, however, looks like there's far more to do. So we've got a little shaded area in there. We've got an equation here. Write this equation in this form where a being constants. So completing the square is the first part that we have to do here. I'll just make a little bit of room so we can work out each part individually. There we are. So first step is to complete the square. So here it's just going to be x plus, and then half of the 6 is 3, and that's going to be squared. Then we have to obviously take away whatever 3 squared is, so that'll be take away 9, and we had a plus 2, which was here. So this is x plus 3 all squared minus 7. There we are, lovely and easy one to do. Obviously I don't leave it with the f of x because it just asked us to change this into this form. Okay, given that C is a minimum point at P, state the coordinates of P. So that's just going to be using our completed the square when we complete the square. So we can say f of x equals x plus 3 squared minus 7. And at this point, it's going to be when this is at its lowest value, isn't it? It's a minimum. So since this can only be greater than or equal to 0, because it's squared, it can't be negative, our lowest point will be, imagine this being 0, so it'd be minus 7 for the y. And when is this 0? When x is minus 3. So our coordinates are minus 3, minus 7. Yeah? So minus 3 is what makes this bracket 0. And that leaves me minus 7 for my y value. Any value in here, even negative, would make this a value bigger than 0 because it's squared. So it's going to be positive, and therefore higher than the minus 7. And it's obviously a minimum. So there we have it, minus 3, minus 7. Okay, now we move on to part C. So the line L intersects C at P and Q, as shown in the diagram. Find the equation of L, giving your answer in the form y equals mx plus c. So we've got coordinates of Q, and we have now the coordinates of P. So we could do it in one go, or we can work out the gradient separately first. So I'll do that. It's not too difficult. I'll start with Q, so I'm going to do Q minus P. So it's the y's on the top, so 18 minus 7, and the x's on the bottom, so that's 2 minus 3. So 18 plus 7 will be 25 over 5. So it's got a gradient of 5. And then I've got the coordinates to 18, or I could use minus 3, minus 7. It doesn't, obviously doesn't matter. I'd use the coordinates given to me though in the question. It's just always better to use ones that are given to you rather than ones you calculate yourself. So y minus 18 equals 5x minus 2. So y minus 18 is equal to 5x minus 10. So y equals 5x plus 8. And there we have part C. And now we have the final part of the question. The finite region R, there it is, bounded by the x-axis L, y-axis and C. Use inequalities to define the regions. Now, in my diagram, I've got no dashed lines. Dashed lines usually mean that it's not equal to, but it would be a greater than or a less than. So they're all going to contain equals, but just be careful on any questions you get. Bold lines means it includes that line, and a dashed line means it would not include that line. So just be careful there. So I'll start with the two easiest ones. We've got the x-axis. So the x-axis is known as y equals 0. We want above that. So that would mean that y is greater than or equal to 0. Next one is the y-axis. Well, that is x equals 0. We want smaller than the y-axis. So we want to take that away, and we want less than or equal to 0. Remember, if you had dashed lines, you would use like just less than in that case. Now comes the two kind of harder ones. So we've got a curve. We want above our curve and below that straight line. So above our curve would be y is greater than or equal to x squared plus 6x plus 2. And then y is less than or equal to 5x plus 8. Okay, and that is because it's below that line. So there we have it. You know, when you're looking at these things, you're looking at from left to right. So as I go like left to right, this ends up below that line, you know. Looking from left to right, there's my line. It's below it. So if you know, sometimes people get a bit confused, is it below it or not? If in doubt, you know, pick a coordinate. Pick a coordinate for x that you know is not on the line but should be below the line, and see if the y value still keeps it below. And then you know whether the inequalities are all true. But that is it. Yeah, hope you find this paper useful, and comment down below. Let me know what you think. If you want me to do some more of these types of practice papers, and of course, like and subscribe if you haven't already subscribed.